Okay, so we're going to be looking at the concept of equidistant today. So, how do you find points that are equidistant from AB? Well, if we were using a compass, we draw an arc like this, and an arc like this. If we draw a line in between them, all these points would be equidistant from AB. This is the midpoint. But also this point up here and this point up here, because of the right angle there, okay, and since this is a midpoint, okay, and since this is congruent to itself by side angle side, this is equidistant to this, okay? So equidistant means that any point on this line, if I draw a perpendicular bisector, any point on the perpendicular bisector will be equidistant from the two endpoints. So that's what the perpendicular bisector theorem says. If we have 2 points, x and y, any point on the perpendicular bisector, because of side angle side, will make this distance from P to Y the same distance as this distance from P to X. Always, always, always. So that's a perpendicular bisector theorem. If a point is on the perpendicular bisector, then it's equidistant from the two sides of the segment. The converse of that is if a point is equidistant from 2 points on a segment, then it must be on the perpendicular bisector. Okay? If a point is equidistant from the endpoints, then it must be on the perpendicular bisector. Okay? So this is the perpendicular bisector theorem, which I just explained. So Mr. Lee can use the perpendicular bisector of a segment that connects the entrances to figure out his problem. Okay? What's his problem? Mr. Lee wants to park his ice cream cart on Main Street, somewhere on Main Street, so that he is equidistant from the entrances of the park right here at A and the zoo right here at Z. He wants to be equidistant from those two, and he wants to park right on the side of the street. So if he wants to be equidistant from those two places where these lines are equal, he wants to park right here on the perpendicular bisector. Okay? Because if he parks on the perpendicular bisector, he's equidistant from both of those points. So, what types of problems are going to explain that? Well, these types of problems. So, when you get to the problems, if it looks to be equal, then you set them equal to each other. These look to be equal, so you set them equal to each other. So if you subtract 3x from each side, 3x minus 10 equals 2. Add 10, 3x equals 12. So x equals 4. If it looks to be equal, it must be equal. If you put in a 4, you get 24 minus 10, which is 14. 3 times 4 is 12, plus 2 is 14. That makes everything equal. How long do you think FG is? How long do you think FG is? 6. If it looks to be equal, you can plan on it being equal. Okay? All right. Boom. Sign in. Okay, you two, I guess. They're going to, are you in it too? Oh, they're going to oral and terp. The bus leaves at 2, so let's see. Okay, so let's look at this thing here. This guy stands, where should he stand to be equidistant from the sides of the angle? Because he either has to jump to that conveyor belt to solve a problem or that conveyor belt to solve a problem. Should he stand there? Should he stand there? Where should he stand? Well, he should stand at a place on the angle bisector of the angle. So if he's the same distance from each side, so is he equidistant? No, that's not the place to be. There, he's equidistant, which happens to be on the angle bisector of this. Oop, I got to play it again. Okay? Because then he'd be the same distance away from each, then he could go equally as easily to where he needs to be. Okay? So as long as he's on the angle bisector, anywhere on the angle bisector, he's the same distance away from each side of the conveyor belt. All right, enough of seeing that guy and all the lines that he's on. Okay? Boom. So if a point is on the bisector of an angle, it's equidistant from the two sides, like we had the problem. Or if a point is equidistant from two sides of the angle, then it's on the angle bisector. So what's the value of KL? To find the value of KL, what do we do with these two? Set them equal to each other. 2x plus 3 equals 4x minus 11. So if we subtract 2x from each side, 3 equals 2x minus 11, add 11. 14 equals 2x, divide by 2, x equals 7. 7. So 4 times 7 is 28. 28 minus 11 is 17. 2 times 7 is 14, plus 3 is 17. How long is KL? It is 17. Okay? So when you see things like this, BAD, CAD, one's here, you just set them equal each other. 9x minus 16 equals 3x plus 20. Okay? And so subtract 3x from each side. Negative 16 6x minus 16 equals 20. Add 16. 6x equals 36. So x equals 6. If x equals 6, what's 3 times 6? What's 3 times 6? 18 plus 20 is 38. Each of these are 38 degrees. Okay? All right, so those are the 4 things that we learned about today. Basically, on this assignment, if they look to be equal, you set them equal to each other, and then you're good. Okay, I'm going to let you have about 20 minutes to work on this, and then we're going to work on constructions, straight edges, and compasses, and that stuff again.